Excellent. Thank you, everyone, for joining us. We've got a great panel here today to talk about next-generation data warehouses. To my left, we have Shankar Venkataraman from IBM. From Teradata, we have Steve Broust. And from Pivotal now, right? From Pivotal, we have Milind Bhandekar. So we're going to launch straight into this. So the description of this panel is juxtaposing traditional and new data processing infrastructures, platforms, and tools. So I thought maybe a good place to start, we could start out with what aspects from your perspective define new versus traditional data warehouse platforms? So what's the defining characteristics of a next generation data warehouse? Maybe we could start with Shankar.
Yeah, so I think the next generation data warehouse is essentially going to be a combination of new types of data combined with existing types of data, and essentially will ensure that you extract information from these new types of data and combine it and be able to extract new types of information in the warehouse itself. So that is one part of it, just at the data level.
Got it.
The other part of it is essentially around analytics, where the data warehouse will basically become the core of all analytics running inside the platform itself. So this is the case of moving function to data. That is the next generation data warehousing platform is going to basically be the fundamental change in behavior in terms of applications and tools and everything else, going from moving data to function to data.
Steve, what would you say are the defining characteristics?
I would agree largely with the characterization there. I think there's one very important piece that defines a new generation, which is this idea of late binding. So rather than adding the structure to the data at load time, you're adding the structure to the data at query time. And there's a very different set of tools and a very different sort of underlying storage mechanisms that you use in order to provide this late binding capability.
Yeah, if I were to describe the defining characteristics of the new data warehouse in just one word, I think it's flexibility. So the flexibility, I think some of the aspects you have already addressed, which is late binding is the flexibility of schema in a way. But this does not mean that the schema is going away. If you have to get any performance out of your data warehousing workloads of future or of today, is going to be requiring schema. It's going to require the same things that you have required in traditional data warehouses like indexes, pre-computed aggregates, right? But in order to do this in a flexible way and while combining various different forms of data, I think that's the defining characteristics of the new generation of data warehouses.
Got it. Excellent. So we've done a lot of research around big data. We've talked to a lot of customers and surveyed customers. And one of the things we've picked up is an increasing willingness of customers to adopt new technologies, to bring on board new data technologies in their organizations, run a greater number of technologies. I just want to see, have you noticed that trend within your own customers? Do you think the door's widening for new technologies to get into organizations? You want to start with Milind?
Yeah, absolutely. I mean, my previous experience was actually with Yahoo when I was on the founding of Hadoop team. So at that time, we basically could not have any technology that existed at that time available at the price point that we were expecting for the scale that we wanted. And that is why I think this whole notion of Hadoop came about in Yahoo. And I think we are seeing the same things, that the traditional technologies have sort of resting on their laurels, so to say, and sort of stopped innovating in terms of scale, in terms of performance, and that's when these new entrants actually came along. The second thing that we are seeing is that the whole headache of deploying these technologies on an on-prem hardware by acquiring hardware, acquiring platforms, and then starting application development, developers within these companies have become more agile and have been allowed to become more agile because of the whole public cloud infrastructure that is available. So rather than waiting 6 months for me to acquire hardware, I can actually go out on Amazon AWS, I can borrow a few instances, and I can start development. Now, the developer side of things are getting actually more agile, but when you look at the infrastructure side of things, when the applications have to get productionized, then you are facing the delays. So how do we bridge this gap between these new technologies coming in from the developer side of things, and now IT has to maintain and operate them? That's something that I think is, again, ready for innovation.
Right. I mean, we could lead into the next question. Not to cut you off, but my next question was around how are these new technologies going to integrate with the existing technologies? And this is a great question for Steve. Teradata, the 800-pound gorilla in data warehousing. how are these new technologies going to integrate with what you guys already have in place? What are the challenges that customers are facing in bringing these new technologies, and what are some of the solutions to bridging that gap, as Milind was talking about?
So I think the point is correct that that people are definitely wanting to use the right platform for the problem that they're solving, and so you're seeing a diversity of technologies emerging in order to do that. But on the other hand, you don't want to sort of lose the value of that in terms of cost to doing the integration. Some of the good work that Hortonworks has done with the H catalog allows you to sort of use that metadata infrastructure we built on top of that to provide something called SQL H, so that someone that doesn't have to have sort of file system programming expertise in order to go get data out of, for example, Hadoop distributed file system. So I think what you'll see is integration of the sort of SQL world and the NoSQL world, and as Eric said this morning, the sort of the 1 + 1 = 3 is a much more powerful idea than sort of change. You don't choose this one or that one. You figure out how to put them together and use the right technology for the problem you're solving.
Yeah, and I agree. That's one of the next steps which needs to be evolved into essentially the whole idea of governance of all of these things, right? So H catalog is the first step there, but we still need to solve the issues around lineage, and because again, flexibility means somebody needs to know what data came in, what was it transformed into, what is it used at, and what solutions are actually leveraging it, and that entire pipeline has to be tracked and governed. And this is one of those interesting challenges in most of our customers, because Hadoop systems right now are sort of engendered in sort of a small 10 node, 20 node, 50 node cluster, and suddenly they boomerang into a 200 node cluster, and then IT wakes up. Okay, and at that point, they say, okay, how do I govern this? Okay, and so that's the next step of evolution, which has to happen as part of big data, where we actually see the convergence of the conventional warehousing capabilities of governance and everything else coming into this new world with flexibility, while still allowing the sandbox and the ability to do experimentation and information discovery on the Hadoop platform and the big data platforms. And this does not just go to just Hadoop alone, right? We have the same issue, same kind of focus on the real-time streaming platforms, right? So you throw a lot of data, much of this data is noise, but the fact is essentially you have to know which part of the data you are using and how are you actually using it in your analysis and your predictions and your scoring.
I think that the agility part you have to be very careful with, because if you introduce too much overhead, then you lose one of the core value propositions. Exactly. And what we're finding is that people will deploy a separate discovery platform that might be different than their enterprise data warehouse infrastructure, for which the lineage and auditability and all that kind of stuff is very important. In the discovery platform, we're typically seeing what I would call no ETL approach, right? We just bring the data in, and then you let the data scientists sort of add the schema at query time and sort of look at the data in different ways. And once you understand the value, then you'll apply that rigor and so on to get it into the production environment.
Yeah, in fact, this is what some of our customers call as the landing zone or the data lake. And this is essentially the concept of bringing it in there, discovering it, and then moving it into your actual application context, if you want.
I think integration and interoperability of these two disparate platforms, the structured data platform and the structured data platform, I think this is only the first step. Right. What the IT and the business is looking for is really, in order to get value from this and to generate a positive ROI on top of from these efforts, I think unification is going to or bound to happen, right? We are basically seeing that more and more of, for example, the traditional data warehousing workloads are now being offloaded onto just this, data lake or data reservoir. All that data is there. What do you do with it? You're not just going to keep it for compliance purposes and for some data scientists to play with it.
Exactly.
Because then your utilization is going to be less than 5%.
Exactly.
And then the IT and business is going to question as to, okay, you have this 1,000 node Hadoop cluster, what are you doing with it, right? More and more analytics is going to move from there. The analytics that is traditionally being done on the data warehousing platform is moving onto the Hadoop platforms, right? So unification is an inevitability. It's not going to stop at integration and interoperability.
Exactly.
That's my feeling.
Do you agree with that, Steve? Unification is inevitable?
I don't completely agree with that because there's certain things, again, use the right platform for the problem that you're solving. So there are certain kinds of batch-oriented workloads that will absolutely move into the HDFS environment, and those are typically more, in fact, production-oriented, not discovery-oriented. Because for discovery, I need a much more interactive environment. I need an environment where I can be very productive. Data scientists are not typically very productive on top of an HDFS environment unless there's another layer on top of that. So you need additional capability. And that's perhaps the unification part that you're talking about. But what good engineers do is they steal the good ideas from wherever they exist. And so what you're going to see are some of the good ideas from the big data platforms stolen into the relational platforms. And so some of the MapReduce capability and graph processing capability and so on, those are going to move into the discovery platforms that are also leveraging the SQL platform. I don't think the HDFS platform is going away, but I think that plays more of a batch processing role as opposed to the interactive, what I would call analytics role.
Oh yeah, absolutely. I mean, so the recent Pivotal HD announcement that we have made, actually, so HDFS and MapReduce, Hive, all of these batch-oriented workloads now actually can share the data on the same HDFS environment on the Greenplum database, which actually allows you to do sub-second or what queries used to be done in hours or used to take minutes on the MapReduce platforms can now take seconds. So seconds definitely is an interactive. The way I see interactive is that, not going for coffee, but just sipping coffee and the result is there, right? Rather than going out for a coffee, getting coffee back, and now you see the result. So I think batch and interactive capabilities are merging. I think it's more of an issue of resource management. How do you manage these shared resources? That's where the focus is shifting. It's not the traditional nature of, okay, this is batch and this, therefore this has to be, and it has to be separate from interactive. I think we have already demonstrated that using the same data, we can actually combine both of those things.
Well, but if you look at, for example, even the Greenplum implementation, right? The data that's in Greenplum is in a different file format than the HDFS data, so it's not shared at all, right? It's on the same infrastructure, but it's not shared.
Well, the Greenplum database data can be shared, can be used in MapReduce, and MapReduce data can be used, or sequence files and your traditional files can be used in Greenplum database. If you store it in the optimized formats, in the optimized columnar formats that are coming up, Parquet is one example, ORC file is one example, then you will get better results, right? So I think what I believe is that there is a peak that everybody is trying to reach, but from different sides. And we are essentially, digging in holes in there so that people can rapidly migrate from whichever side they are on onto the other side. Eventually, they are going to converge at some point.
Yeah. So the issue here is this, right? Ultimately, you have to look at it from the point of the person who is doing the interaction. Okay, the interaction tools are essentially based on. Essentially, right now, most interaction tools have data access parts is essentially SQL.
Yes.
Okay. So ultimately, be it unstructured data, be it structured data, you need a way by which SQL needs to be the vehicle for an application programmer to get at it. Now, there are scripting languages on top, which is going to happen. Okay. But the bulk of the tool sets and the bulk of the applications that you have right now essentially are all SQL based. So that's where the next generation of SQL in terms of SQL MR standardization, say the standardization over the Hadoop system itself. Like right now, if you say I'm using SQL over Hadoop, you would say, oh, I'm using Hive. Okay, now what stops us from actually doing a abstraction of the data placement itself? Like why should a company like his application need to know whether they're going to put data into HBase or Hive or a flat file or whatever other new data structure can sit on HDFS.
Yeah, we used to. I mean, I've seen this trend in Hadoop Summit as well. Is last 5 Hadoop Summits, everybody was talking about how we are not SQL, and now over the last year, there have been like some 20 companies and 20 implementations that said we are the SQL on top of Hadoop, right? So that's sort of where
and it's bound to happen because ultimately you have way more SQL programmers than Animal Farm programmers.
Absolutely.
That part I understand. So we're going to move to a question about dollars and cents, showing my lineage from Wall Street versus the technology guys here. how are end customers funding this? How are end customers funding these new data warehouse technologies? Basically, where are the dollars coming from? Are they taking it from other data management technologies? Is it a shift from other parts of the IT budget into data management? Or is it incrementally just we're putting more new dollars into IT?
My experience would be they're creating new value, right? So there's data out there for which the value density is friendly towards a Hadoop environment, which has a different set of economics, and the data, the structure of the data is friendly towards an HDFS environment, so they can go get value that they couldn't get access to before at the right price point in an enterprise appliance for doing data warehousing. So what we clearly see is that it's incremental, right? Okay. And it's data that you have not seen in a data warehouse before. You're starting to bring it into the environment. And I object to this term unstructured data. I think that that's completely wrong. There is no such thing as unstructured data that's interesting, right? The unstructured data is a random series of zeros and ones. All data has structure. The question is, what is the structure and how to create the value from that structure? I know as an industry we simplify it for CEOs and call it unstructured data, but that really misleads people in terms of how to get the value from it.
Let's compromise, right? Let's call it polystructured data, okay?
Or multi-structured. So just introduce two more terms in there to confuse the CEO, right?
So the thing is, so what we have seen is essentially there are two sets of funding which is coming, okay? One is on the higher end where there's actually value-added ROI happening because of new types of analytics, new types of data and information being applied to solve real problems, like being able to harvest profile information and social information and combining it with your master data information and being able to put new offers which is heavily micro-segmented, right? Like for example, we can basically accumulate something like 1 million users' profiles out of social data in about 3 months and be able to literally predict when somebody is going to move or somebody is going to actually buy a new house at a level of prediction which is not unheard of, like which is actually causing people to actually get close to 30-35% uplift on their campaigns. Okay.
I think
now the other end is actually on the cost side, right? Yeah. Where people are saying, okay, I'm spending way too much on my existing infrastructure. I need a place where I can do this at a cheaper fashion, but they do expect the same performance. Okay, this is again goes back to our previous discussion around SQL and performance and everything else. So that's where the progress has to happen.
Yeah, I think you're seeing a lot of press about these new insights, the new discoveries that can be made. If you look at the dollar amount that is being spent typically on the Hadoop infrastructure, I think most of that is coming from the traditional data warehouse offloads. Typically the ETL offload, because somehow ETL is thought of as a low value thing for which I'm spending 40% of my warehouse budget. Why can't I move that out of
exactly?
It, right? So the new platforms are actually coming in, at least the dollar amounts that are going to be spent on that, currently being spent on that, are coming from there. And since a few of the use cases have really gained prominence, is this micro targeting, if you want, these are getting a lot of press, and that's where that basically just raises the visibility of these new platforms.
So I'm not really seeing that. Well, first of all, if you're spending 40% of your data warehouse on ETL, you've already got a problem.
That's true.
And if you look at the tools available in an HDFS environment for doing ETL, they're very primitive compared to what is in, I'll say, the traditional ETL space. I mean, that's not our space, but when I look at our partners and their sophistication, right, their direction is clearly towards moving that processing into that area, but it's not yet anywhere near mature, right? Yeah. So most of the ETL that's getting done on HDFS environments is hand-coded pig and Hive and things like that, which means that you would be insane to do a complex piece of ETL. It'd be like doing ETL in the 1990s.
That's
right?
true.
With
that's
no
not,
metadata.
That's not entirely true, though. Okay, you should. So coming from an ETL vendor, okay, so I can tell you that we are actually moving workloads into Hadoop using the exact same pipeline. Okay, all we have to do is actually say the same exact. This is classical moving function to data is actually happening. Okay, on the ETL space. In fact, it's become ETL is no more ETL. It's ELT. essentially happening with our existing ETL infrastructure on information server.
I think
that's
you're
something
confusing your PowerPoints with the actual code,
no,
right? Because if you look at what's really being done there, the Jackal code that's being generated is not nearly the level of sophistication as what even data stage would do in the traditional platform.
What I'm saying is, to say that it's going to be complex is not it's not true. Where it is actually starting to get there. That's all I was getting.
A lot of ETL actually tends to be a lot simpler than some of the deep analytics pipelines that I have seen, right? And which basically means it's if I were to choose one pipeline, one analytics to move outside of the costly data warehousing infrastructure, I'm going to choose ETL. And that's what I basically see happening. Plus the flexibility of the Hadoop platforms, which basically I don't have to write a complex 300-line UDF in order to, and in a particular language, in order to interface with the data warehousing platform. I can write a shell script. I can write a script in Perl, Python, etc., embed it with my Hive, my pig jobs. And now I have the same sort of complex capabilities of the ETL, in the ETL pipeline moved outside of Hadoop. Right? So this flexibility is actually helping a lot. I don't have to go to a DBA saying this is the script that I have, can I run it, or UDF that I have, can I run it inside the data warehouse? I don't need that because the Hadoop platform actually gives you a lot of nice process isolation, resource isolation that I don't actually interfere with other people's jobs, and therefore, yes, I'm free to run whatever I want. Right? So I think that is the property of Hadoop that is helping offload from these costly data warehousing platforms. You don't agree?
I don't disagree that ETL is a good candidate, but I think we're doing a disservice to Hadoop to say that that's all it's capable.
Oh, that's not all. That's not. Absolutely, I'm not saying
that. So I think that there are certain other kinds of processing, which I would call value-added processing, which are not just in the ETL space. So for example, if I'm a healthcare company, I might be taking data and doing what we would call ETL and Hadoop for some of the data, but I'm going to do much more than that. I'm going to do analysis on the non-traditional or polystructured data to extract value that then I can put in the data warehouse. So you can call that ETL if you want, but I think that it gets a lot more interesting when you do the beyond ETL stuff, because the traditional ETL stuff, what value am I adding? I may be doing some cost takeout, but I'm not really adding a lot of value. And I think that there's a lot of Hadoop Kool-Aid being pulled out there. You know, it's free, so let's go do it. Well, you know, open source software is free like a free puppy is free, right? So I can give it to you for free, but if you think you're going to be successful without investing in your people and infrastructure and so on, then you're wrong.
I think given better interfaces, people tend to pick up you are essentially hiding the complex Hadoop interfaces, right? Yeah. If you can do this same stuff in SQL or any of the interfaces that you are already familiar with, why won't you do it? Right? One of the initial sort of turning point for Hadoop in adoption was something called Hadoop streaming. It was nothing related to the streaming technologies, but it was just ability to write your map and reduce functions in any language that is possible. Just democratize. You don't have to learn Java in order to work with Hadoop. You can just so that's what I'm seeing, that the flexibility of programming or choice of programming languages, the flexibility of programming models, I think that is going to emerge, and therefore it is going to become more democratic, and that's where your initial developers are going to be trained on that. They already have access to these open source technologies. They can just download it off for free and start playing with it. So by the time they come out of school, they are going to be trained in these technologies. So I think the talent gap is going to be bridging, and therefore a lot of these complex platforms are going to be moving on to Hadoop. That's sort of inevitable, I think.
Okay, I want you guys to help me with one of the key debates going on Wall Street that's around Hadoop. And we're trying to understand how far along the maturity curve are. Is this something that's going into production environments? So everyone want to give the answer on a scale from 1 to 10, 1 being an early stage open source development project, 10 being production ready like IBM DB2. Where do we think?
I mean, obsolete.
Hey, watch it.
We'll call it production ready. Where do you think Hadoop is today? Well, we could start with Shankar.
I think it's at about between a 5 and a 6 right now, okay? Because we do have early adopters going into production, okay? But is it actually easy for them to go into production? I wouldn't venture to guess that, okay? Everybody is doing a little bit of heavy lifting, and we are actually helping them do the heavy lifting. But there are people in production now. there's a difference between an enterprise customer going to production versus a cloud customer going to production, right? The cloud customer essentially is a DevOps shop most of the time, okay? And they can throw a lot of bodies at the DevOps nature of Hadoop right now, okay? And hence they can go into production a lot more easier than actually a classical enterprise shop like your bank, for example, right? And that is the level of maturity which needs to happen, where anybody, be it on-premise or on the cloud, can get the same facility of moving into production with the kinds of controls you need around that.
Steve?
I would observe that the second half of 2012 was really a tipping point, because prior to that, most of at least the customers that I worked with that were serious, not just tire kicking, not just IT in a lab somewhere, but doing something real with it, were mainly in the .com industry, right, mainly. The second half of 2012 was a huge tipping point where you saw sort of mainstream, banks and telcos and retailers making real use of the data. Right. Maybe for point applications in particular areas, but they were making, value-adding use, not just IT tire kicking. So I think it has kind of, in Jeffrey Moore's term, crossed the chasm into the sort of early mainstream adopters that have a very different set of buying criteria. It's not about the technology, it's about the value add, it's about how to integrate with the rest of the enterprise and all those kinds of things. So yeah, we're, if I were to put a number on it, I think 5 is probably a good number. You don't really want to be past 7, because then you're, then you're on the downhill side, you're on sunset, right? So 5 is a good number.
Well, I would say the HDFS, the storage part of Hadoop, is around 7, whereas the rest of the compute that is integrated on top of that is around at 3. And that's why the whole Hadoop stack comes at 5. Okay? So I think HDFS is a rock solid substrate for big data analytics storage. There is a lot more work needed on the upper level compute stack, and I think a lot of people are doing that already.
I think,
I totally agree with that.
I think that's absolutely true.
And I think that, one of the things that is very important right now is that as an industry, we don't allow Hadoop to get hijacked like Unix got hijacked in the early 1980s, right? Because you remember in the early 1980s, there were really only 2 distros of Unix, right? The AT&T System 5 Release 4 and the BSD release. And if we lose the open source nature of Hadoop, we're going to get 50 versions of Unix or 50 versions of Hadoop like we had on Unix, none of which add enough value to justify their existence, but they all cost us a lot of money. So it's very important as an industry that we keep Hadoop in the open source world so we can continue the innovation and we can protect the economics of it, because the economics of Unix, in the 1990s destroyed us, right? Because it's not about the cost of the hardware and the software, it's the OpEx of managing all these different versions and porting utilities and all this kind of stuff. What a disaster. And it took us, 20 years, and we're still trying to get rid of proprietary Unix out of our data centers.
Thanks. I think it's a necessary but not a sufficient condition.
Yeah.
It's a necessary condition, but just having open source does not mean that the distros won't, proliferate. At one point, there were something like 30 Linux distribution, and Linux has always been open source. Right?
All right, guys. Interesting discussion. You are 2 minutes over. I'm sorry, I've got to cut you off, guys. Thank you very much. Audience, please give them a big round of applause.